Right, let's keep going. And we were making maths, right? Yeah, we've done that. So in this third example, we've got, I don't know, a calculator here. Determine whether the line y equals x minus 5 is a tangent to the circle, that circle there. Okay, so what we need to do here is, if we've got some sort of circle and there's a tangent, why is that first line, I'm going to call it line 1, a tangent, whereas line 2 is not a tangent? What makes line 1 a tangent if I drawn it a little bit better? Well, I say a bit better because, of course, it's meant to just touch the circle once, and that looks like it's touched there as well. But, okay, so a tangent touches the circle once. Now, if we want to see, we've got this line here. Let's say that this is this line. We don't know if it's going to be a tangent or not. And we've got our circle over here. How do we normally solve simultaneously? How do we see if two graphs, when they're equal to each other? Well, we normally, make them equal to each other or substitute this into this equation, right? Wherever we see a y, we're going to put that y. So once we've substituted this in, let's show that step. So we've got our x squared minus 4x plus y squared, but now y is x minus 5 squared, and we're going to go equals 5. So we've taken this equation here, maybe we called that one 2, and we called this equation 1, and we wrote we're going to put 2 into equation 1. Maybe we were kind enough to write that, but maybe we weren't, so be it. Now, if we solve this equation, we're going to get value or values of x. How are we going to interpret that? How are we going to know whether we've got a tangent, like L1, where it touches once, or not a tangent, like L2, where it touches twice, or perhaps there's a third option. We might find another line here, L3, where it doesn't touch at all. How are we going to know which of those scenarios we've got? Well, if we've got L1, we'll solve all of this and we'll get one value of x, right? Because x is definitely going to be that value. If we have this scenario here, we'll find that there are two possible values of x representing the two different coordinates. And of course, if we have this last scenario here, well, then we won't have any values of x because there aren't any solutions. So let's see, how many solutions have we got? That's going to tell us. So go for it. X squared minus 4x plus x squared minus 10x plus 25 equals 5. Keep solving that. And the key question is, how many solutions do you get? And therefore, is it a tangent or not? Okay, so I'm going to do it here. I've got, I don't know why I put an x squared there, getting overexcited. X squared plus x squared is 2x squared minus 4x minus 10x is minus 14x plus 25. I'm going to subtract that 5, which means we've got plus 20 equals 0. Okay, I'm going to make my life easier and just divide through by 2. Now, you could put that into the quadratic formula, or if you're feeling like you're up for it, you can always try and factorize. I reckon minus 5 minus 2. So the key point is that there are two solutions. It doesn't really matter what they are. They're two real solutions. So therefore, it is not a tangent. Because there are two answers, which means we've got something like this yellow line going on because we found two different answers. Okay, so that's if it's a tangent or not. Okay, this question, I've drawn the diagram, I've shown you the diagram to work with, and that is, show that the circle x plus 3 squared plus y minus 4 squared touches the circle x squared plus y squared equals 9. So if it says it just touches it, how many times does that mean it touches it? Well, it means it just, I don't know either. It means it just touches it once, right? So what we need to somehow show is that there's only one point over here. We don't have a scenario like this, and we don't have a scenario like that. It's not going to touch twice, and it's not going to touch. it's going to go there and it's going to form a nice snowman and touch just the ones there. Okay, so I'm just going to kind of work through our logic of high level what we're going to do, and then let's work out let's work through the details. So if it touches once, if we draw a line from this center to this center, and we work out its distance, and that is equal to the distance, that radius of the bigger circle maybe, and plus the radius of that one. So R1 plus R2. So in other words, if R1 plus the value of R2 is equal to that distance between the centers, well, then it must touch once. Because look what happens here. If we look at these two circles here and we take this radius and we take the other radius up here, well, if those two add them up and it's smaller than the big distance between the two, then this distance over here, clearly they're not touching, right? And similarly, we could say here's a center, here's a center. If we did the same thing here and we went this radius over here, whoopsie, let's do that. This radius, let's say that radius was 7, and the other radius over here, there, were like 3. Well, clearly the distance between these two circles, this distance here, is not going to be 10, right? It's going to be a whole lot smaller than 10. But if it works out perfectly, then they must be touching once. Okay, so that's our high-level picture. So let's do this. Let's find out what these radii are. So let's call this one radius 1, which is for this one here. What is the radius of that bigger circle centered at the origin? Well, it's 3, right? Because that's r squared. Let's do the other one. This radius here, the smaller one. So that relates to this part over here. What is the radius of the smaller circle? Well, it's 2. How are we going to work out what the entire distance is between these two centers? How are we going to work out what that distance there is? Well, I can kind of imagine you might say, draw a triangle and use Pythagoras. Maybe you said use distance formula. Of course, they're going to be the same thing. So let's call that whole distance d. In fact, we can probably see it because this distance here is 3. This distance is 4. So therefore, what is the value of d? Well, it's 5 because it's a nice Pythagorean triple. But if it weren't such a nice Pythagorean triple, we would just use our distance formula and go squared plus whatever squared. You know that distance formula, you've been practicing that, and you would find out that the distance is 5. But certainly just draw a triangle in this case. So therefore, because all of this works out, because the two radii, when you add them up, they're just the same as that full distance, well, therefore, we can say, well, it doesn't ask, does it? We've shown it. So we can go, yes, it does touch the circle once. Okay, cool. So let's think about heading into our last example. We're given the circle. I don't want to keep running with it in this video because we've got all the energy, right? Okay, so yeah, again, just drawn the diagram in. We've got a circle, and we're told that the center here is 2 minus 5. We could read this off from the equation here. Now note that here's the equation you were given. I've given you it in this nice center radius form because you've got enough time to practice that. I don't want to spend lots of time in the video doing another one where you complete the square. We've practiced that, but it might not be given in nice center radius form, but it has been, yes. So we've got our center here at M, which is at 2, because we could read that off there, and minus 5, because we could read that off there. What's the radius of the circle? Must be getting tired of that question, but it's so useful because the radius from this, the radius is 6. So therefore, what's the value of the distance PM? Well, PM over here is 6, right? Isn't that just the radius? how are we going to work out what the value of, let's see, don't we have a nice orange here, what this distance MQ, how are we going to work out what the distance MQ is? Well, I would just go for straight up that lovely distance formula. We just referenced it, and now we've got a nice chance to use it. So you just go x minus x, 8 minus 2 squared plus 3 minus 5 squared, and into our beloved calculator that goes. So while I put it into my calculator, what is the value of MQ? Okay, well, I'm going to do it here while you're doing it. 8 minus 2 squared plus 3 minus 5 squared, whole thing square rooted. Well, I get 10. Okay, so if this distance is 10 and we're in a right angle triangle, whose theorem are we going to use? And what is the value, what is the length of PQ? Well, of course, we're going to use Pythagoras, and this ended up being quite a nice Pythagorean triple, 3, 4, 5, so PQ equals 8, because we just used Pythagoras. Hopefully we get lucky, 6, 10, 8, and it works out nicely. Otherwise, you could have just gone this squared plus this squared equals this squared, and it would have taken a bit longer. Okay, so that's that. You've got exercise, I think it's exercise 4 to do to practice those. So whatever's left of today to do those and into tomorrow. So enjoy, and of course, as you do enjoy that, don't forget to make it maths.